Hey, and welcome to my new video series. This series is going to be about Liwa Tower in Abu Dhabi. Liwa Tower was designed by a well-known Dutch architect, Kas Oosterhuis, and his wife, Ilona Lenard. They won an international competition in 2006, and this building was built in 2014. I like this building very much. I like the silhouette of the building. I like the curves of the silhouette, and I love these panels. I think it's very nice building, complex in its design, and it definitely stands out in its own surrounding. Liwa Tower is an office building. I think that the silhouette of the building was designed in Rhino, and then I think that the panels were generated with help of Rhino script. I'm not sure. That's just my lucky guess. We are going to use paneling tools in Grasshopper to generate the panels, and we will draw the silhouette of the building either in Grasshopper or directly in Rhino, and I will show you how to draw the silhouette of the building. You can go to skyscraper.com, building Liwa Tower, and save this elevation. As you see, the tower is 85.6 meters, and yeah, it consists of 20 floors. You can see here. And in order to draw the silhouette of the building, go to Architizer, I think, and save this drawing, this one. We are going to need these 5 profiles in order to draw the silhouette of the building. And here you have you can see the competition proposal, these 4 images, and that's the building, the construction work, and interior design. You can see that the columns follow the design of the panels, and this is work in progress. And you can find a lot about this building on internet if you want to know more about the building. Now let's open Rhino and Grasshopper. I'm using Rhino 8. And as you see, I have already imported this elevation that I found on skyscrapercenter.com. As for the profiles, I will explain how you will draw them and where to place them. I did my profiles in Grasshopper, but you don't need to do that. It's quite tedious to do that in Grasshopper. You just go to Rhino and redraw the profiles from this drawing. I changed this view to the top view. And as you see, I have already done the silhouette using Grasshopper. Don't do that, it's quite tedious. I will turn this off. I draw this vertical line. That line is 85.6 meters. That is the height of the building. You can see it here. And then I generated 21 perpendicular frames. You can see here the result is 21 locally defined values, and the input value is 20. And these planes correspond to the position of the floors. Turn this off, and let's go to our profiles. Basically, the starting point is this rectangle that is 34 by 40 meters, and each side of the rectangle is divided in 2, and we are going to manipulate these points according to this sketch that you downloaded from Architizer. As I said, this is the starting point, and the next step is to manipulate the profiles according to the sketch from Architizer. And you see, here is my first profile, and I placed that profile at the bottom of the building. I turn this off, and let's go to the new profile again. The starting point is this rectangle, 34 by 40 meters, and these 8 points. And when you manipulate these points according to this drawing, you get this profile. This profile I placed at the level 2. Let's go to the next profile. I turn this off. Again, the starting point and the result according to this drawing. I turn off the starting point. This profile I placed at the level 12, I think. Let's turn this off. and go to the next starting point. The same starting point as always. And the result is, and this is the result. And I placed this profile, I think, at the level 16 or 18. Just place it according to this elevation drawing. Preview off, and let's go to the last profile. Starting point and the last profile, the result. And I placed this profile at the top of the building. I will turn on all the profiles before we start drawing or generating the curves between the profiles. And let's go to perspective view. So, and we draw the curves from this point to this point to this point to this and last point. Let me show you the result. So this is our first curve, this is our second curve, the third one, and the rest of the curves. I turn them on at the same time. That's our curves that are going to form the surfaces that define the silhouette of the building. And this is our first surface, the second one, the third one, the fourth one, and the rest. That's the silhouette of the building. You can see this elevation is correct, and even this one if you compare to the build result, but this side of the building doesn't correspond to the build result, but it corresponds to the competition proposal. I couldn't find the profiles for this resulting building, so we are going to work with this silhouette, and it doesn't matter if we are going to work only with one surface. It's quite complex building and you do not generate the panels in a day. And the last thing that we need to do before we go to paneling tools in Grasshopper and before we generate the panels is to draw the panel that we are going to project on the surfaces. And I generated the panel also in Grasshopper. You don't need to do that. It's a lot of code for a little panel, I think. You can draw it in Rhino and import the panel in Grasshopper as a wrap, I think. And this is my panel. As I said, quite a lot of code for this little panel, but I will show you how to structure the panel. I will turn off everything and then go through the design of the panel step by step. Basically, what you are going to do draw these 4 lines. This line is 1000 millimeters. This one is 1500 millimeters. And then we can draw a diagonal between these 2 points. I turn off the points. Then we will offset this side, and this diagonal by 100. And trim the lines, and this is the result. You cannot trim in Grasshopper, but you can trim in Rhino. In Grasshopper you find the intersection between the lines. And here's the result, the lines that are offsetted 100 millimeters. And then we will divide each line. We will find the middle point on each line, and together with these intersection points we will generate the NURBS curve through these points, and the curve looks like this. And let me turn off lines and even the points. So that is the first opening in the panel, and the second opening we will design like this. We will offset this line, and this diagonal by 200 millimeters. Trim or find the intersection points between the lines. If you are doing that in Rhino, you can trim the lines. If you are doing that in Grasshopper, then you need to find intersection points. That's how I did that. I turn off these lines, I don't need them anymore. And then I draw the lines between those points and find the middle point on each line. And let me turn these lines off. And then we will generate the NURBS curve between these points, and the result is this. I turn off the points. So that's our second opening, and then go and extrude the rectangle and do boolean for the openings. This is my result. We are going to project this panel on one of the surfaces that we are going to work with. And as I said, we are going to work with paneling tools in Grasshopper. I don't think that Kas Oosterhuis used paneling tools for this building. First of all, we didn't have Grasshopper at all in 2006. The first version of Grasshopper was released in 2007, and I think it was called Explicit History. I think that they designed the silhouette of the building in Rhino and then used Rhino script in order to tessellate the surfaces. But we are going to work with paneling tools in Grasshopper. I have already done some pre-studies in Grasshopper and even in Revit. We will generate grids with help of paneling tools, and we will use grid point to generate the panels and even for the columns. And then we will move all the information from Grasshopper to Revit. We are going to use this level of detailing for paneling. I will explain why. So that's all for now. Thank you for watching.